Hello, everyone. We are Project 21090, and our project was the AZ Water Student Design Competition, where we designed a new Gilbert water treatment plant. Our project team consists of myself, Gabriela Diaz.
I'm Ariel Brookshire.
I am Stefan Muadlim.
I'm Mohammed Al-Mahiri.
Here's our project poster, which we will explain and go through in more detail throughout the presentation. We had the opportunity to work with the town of Gilbert at their North Gilbert Water Treatment Plant facility. They proposed to us a project where we figured out ways to prevent the production of disinfection byproducts. We were tasked to redesign the treatment system and in the process expand the current plant to be able to handle a greater water demand due to the town's increasing population. The problems that we were faced with and had to construct our design around was to be able to efficiently reduce and possibly eliminate disinfection byproducts in the reservoirs. We proposed doing this by reducing the total organic content, or TOC levels, to be at or below 2 milligrams per liter. When finalizing the effluent water quality, we proposed to apply by EPA drinking water qualities to ensure the finished water was suitable for the community. We also had to assess the other issues. In doing so, we needed to think about expanding the new water treatment plant to accommodate for Gilbert's population growth. With an increase in population comes an increase in water demand. And finally, once the design steps were done, we needed to estimate the costing and construction of the plant. Now to give some background information about the water treatment plant we were working with. As mentioned before, the North Water Treatment Plant is located in Gilbert, Arizona, and was first built in 1990. It was originally designed to only be able to handle a capacity of 15 million gallons a day. Over time, the population and city grew, increasing the capacity to 30 million gallons a day, and then eventually to its current capacity of 45 million gallons a day. The North Water Treatment Plant uses the Verde River and Salt River as its main source of water. These were the influent concentrations that we were working with. Finally, in the year 2050, the town of Gilbert would have an estimated population of 300,000. We use this information to determine the new water demand for the plant.
For this project, our group looked into 4 different alternatives that would overall reduce the total organic carbon levels and would not increase the land requirement for the plant. The first alternative was enhanced coagulation, which used an increased dosage of coagulant. This would have come after the flash rapid mixing and before the 3-stage flocculation in the process. The second alternative that was considered was the addition of ozone, UV, and back filters. For this alternative, UV radiation units would be added after the ozone treatment, and the biological activated carbon filters would be added before the granular activated carbon filters. The reason to add these pieces of equipment is to create an advanced oxidation reaction, which in turn will increase organic matter from UV and ozone that is able to be picked up more effectively by the back filters. Nanofiltration was the third alternative that was considered for the new North Water Treatment Plant. This alternative consisted of the addition of a 3-stage nanofiltration process after the final sedimentation basin and used ultrafiltration as a pretreatment. Ultrafiltration is meant to filter out viruses, bacteria, and other pathogens, while the nanofiltration removes the monovalent and multivalent ions. The final alternative considered was the addition of microsand to the 3-stage flocculation process. For this alternative, microsand is added to the first stage of the 3-stage flocculation, and a hydrocyclone gets added, which is where it separates the sand from the sludge that is produced from the final sedimentation basin. The sand that is separated from the solids is added back into the flocculation process, and the solids that are separated out are then sent to the sludge thickeners.
After researching information on each alternative, it was time to evaluate them to find the best design for the new Gilbert water treatment plant. The alternatives were evaluated in a decision matrix under 3 categories: economic, social, and environmental, and were ranked 1 to 4, where 4 is our best alternative in that specific criteria. The economic category had a couple of criteria: initial investment, operation costs, and the amount of chemicals used. The social category had criteria such as constructability, maintenance, personnel, and staffing levels. And finally, the environmental category had criteria such as energy usage, solids produced, and greenhouse gases. As shown in the decision matrix, the alternative with the highest total points was the microsand filtration, and thus it is our chosen alternative for our new water treatment plant design. The new Gilbert water treatment plant will include a microsand filtration in the three-stage flocculation process. The microsand filtration alternative had the highest points in the decision metrics for a couple of realistic reasons. First, it satisfies the first requirement of the problem statement that was given to us by the 2021 AZ water competition, which was to reduce the total organic content or TOC levels below 2 milligrams per liter. Second, it is one of the cheapest alternatives in terms of capital and operational costs. And third, the equipment produces least amount of greenhouse gases and requires least energy usage. The equipment also limits the amount of waste solids produced, which reduces the solid management process in the plant.
Since the new design only adds small changes to the original plant, the PFD looks similar to the original. Water will be coming from the river through the canal intake, and it will go through the bar screening where large objects will be removed. From there, the water will go through pre-mixing and into the pre-sedimentation basins, where the solids and turbidity will be reduced. Next, a low lift pump will be used to send the water to the ozone chambers, which will be used to disinfect the water. After that, the water will go through rapid mixing where flocking agents will be added. And from there, the water will go through the three-stage flocculation basins where we can start to see the new changes. Microsand will be added during the first stage. Water will be mixed slowly, which will cause the particles to form flock. After that, the water will go to the final sedimentation basins where the particles will be removed. The sludge coming out of the basins will be sent to the hydrocyclone using the microsand pump. The hydrocyclone will recycle a percentage of the microsand back to the flocculation basins, and the sludge will be sent to the sludge thickeners. The water stream coming out of the final sedimentation basins will go through GAC filtration. Finally, the water will go to the reservoir, and from there it will be pumped to the final destination. After evaluating all the alternatives, microsand filtration appeared to be the most suitable alternative for the new treatment plant. Due to the minimum changes to the original design, the recycling of the microsand, and with no need for additional chemicals, microsand filtration was the cheapest alternative, had little environmental impact, and lowest energy usage. The new design satisfies the TOC levels requirement from the problem statement and meets the EPA regulations. With a treatment capacity of 54 million gallons per day, the new design also accommodates the increase of water demand due to the population growth by the year 2050.
Here's our project poster once again, and this concludes our presentation. We thank you for your time.